All right, welcome back, Stats. My lovely wife's last phone call interrupted that one and made for a 200-second video. We're going to try to go a little bit longer here in this video. All right, so as I was saying, there's the formula for variance is the sum of the individual deviations squared divided by n minus 1 to make it an unbiased estimator. There you go. There's the formula. N minus 1 is what you're dividing by. Standard deviation S is the square root of the variance. So we need to figure out what the variance is first. You take those individual x's. So 4, you subtract 10, square it. 9, you subtract 10, square it. 12, you subtract the mean, square it, and so forth. Remember, when you square a number, it's always positive. Add them all up. That's 164. Divide by 6, not 7. Then you get 27.3. Repeating, immediately take the square root of that answer. So it really should actually be, that's what we're looking at. And your sample standard deviation is 5.23. The mean is 10. All right. That one definitely on there. Anyone I do is definitely has a good chance of being on your final. Let's just say that. The probability distribution of the first digits of numbers in legitimate records is given below. What is that? Binford's law we talked about earlier this year. X is the first digit. What is the probability that the first digit is 2? So what's the probability that X is 2? I will want you to make some probability statements there, and I'll mark it on your final when to make a probability statement. So that is missing. So I'm going to do 1 minus the probability of all, the sum of the probabilities of all, getting all the other numbers first. There you go. What's the probability that the first digit x is greater than or equal to 6? So the probability x is greater than or equal to 6. We'll add the probability at 6 plus probability at 7 plus probability it's 8 plus the probability it is 9. Easy. The following table gives the sex and age group of college students at a Midwestern university. So there's the data. Find the probability that the selected student is female. So probability of female is that divided by the total. Given that the selected student is female, find the conditional probability. She is 25 to 34 years old. So given that she's female, that means 9321 is the denominator. What's the probability she's between 25 and 34? 1904 is the numerator. All right, you do have to write those statements. Given a coefficient of determination value, r squared, and the sign of the respective linear regression model slope, state its correlation coefficient, the r value. So if r squared is that and the slope is negative, you simply take the square root of 0.924. Make sure to put a negative on the outside, though, because when you square any number, r squared is always going to be positive. There's b, take the square root. It's positive because the slope's positive. The sign of the slope matches the correlation coefficient. If you have negative slope, you have negative correlation. Positive slope, positive correlation. Take the square root. It's positive. Take the square root, but attach a negative. Take a square root. It's negative. Take a square root. It's positive. All right. That one, is done. Then, number 8. Given the following correlation coefficients, R values, state the 3 strongest and the 3 weakest. The 3 strongest would be the R values whose absolute value is closest to 1. So those 3. The 3 weakest would be those whose absolute value is closest to 0. Would be those 3. Birth weights at a local hospital have a normal distribution with a mean 110 ounces and a standard deviation of 13 ounces. So let X be the newborn weights. Find the probability a randomly chosen newborn has a weight of more than 120 ounces. Find the probability that X is greater than or equal to 120. You can just use greater than or equal to, less than or equal to for any statement there. So Z is 120. That is your X minus the mean 110 divided by the standard deviation. Your Z score is 077. Get out your Z table. I'll give you a link to one. You guys should have about 8 in your possession. 077, if you look it up, it has an area to the left of 7794, but you want greater than or equal to, so you got to give the complement 2206 as your answer. How much must the newborn weigh to be in the top 10%. Top 10% is the 90th percentile. You go to your z-table and you look to find what z-score has an area to the left closest to a 90%. It's right there, and that is the 1.28. So 1.28 is equal to x minus 110 times 13. 13 times 1.28, then add 110 to it. There it is. Consider a random sample of 16 newborns in a hospital. What is the distribution of x bar? X bar is normal. Make sure you put out normal. All right, with the same mean and the standard deviation is the standard deviation over the square root of n. We can do this because x did follow the normal distribution. All right, 110 with a standard deviation there of 3.25. That is the sampling distribution. Find the probability that x bar is between 110 and 120. Well, we know 110 is the average, is the mean. That's going to have a z-score of 0. If you look up 0 on the z-table, you get to 0.5000. Z is 110 minus 120. Again, we're dividing by 3 1/4. This is what's the probability that the mean of those 16 babies is going to be between those two values. All right, so that's going to give you a z-score of 3.08. Look that up, 9990. So the probability that x bar, the average weight of those 16 babies, will be between 110, the average, and 120. It's going to be 9990 minus 5000, basically 50%. We've done the IQ question a bunch. IQ scores are normally distributed with a mean of 100 and standard deviation of 16. X equals IQ score. What is the probability a randomly chosen adult has an IQ score of 120 or higher? So probability x bar greater than or equal to 120. Find your z-score. Look up the area. The area to the left is 8944. You want the area to the right, though, so the complement is 1056. What's the probability a randomly chosen adult has an IQ of 85 or less? Probability x is less than or equal to 85. X, not x bar, because this is a randomly chosen adult. 1, not the mean of 30 of them or whatnot. I keep that area because the area to the left is what I'm looking for. And then what's the probability that a randomly chosen adult has an IQ between 110 and 130? There's your probability statements. Okay, z-score for 130, the area to the left. Z-score for 110, area to the left, and you subtract the 2. That question then is done. Take your time going through this. This would obviously be the thing to use on your take-home final. SAT math scores are normally distributed with a mean of a 515 and a standard deviation of 107. So x equals the math SAT score of an individual. What's the probability a randomly chosen student will score between a 550 and a 650 on the SAT math? There's your probability statement. The z-score for getting a 650, there's the area to the left. So you'd basically be in the 90th percentile. The z-score, sorry, Yogi, whose only job, it seems, now is to bark at anything. 1 second. And we're back. The z-score for getting a 550 would be that 033. The area to the left is 6293. Subtract the 2, and that would be the probability of scoring between a 550 and a 650. Okay, the following is the least squares regression equation for the number of class days missed, which is the explanatory variable, and the overall semester grade earned. State the slope and the y-intercept and interpret what they both mean in context of this example. The slope is negative 2.78. You can't simply just state that. That means for every class that is missed, every day that is missed in class, the grade decreases by that many points. The y-intercept is 93.49. That means if you miss 0 classes, that's the grade you're going to get. Again, the y-intercept on its own in a linear regression model is not that useful. Predict the semester grade for a student who misses 8 classes. Well, X would be 8. Plug that in, and their predicted grade would be about 71.25. Find the residual, which is y minus y hat, for a student who misses 9 days yet earns an 87. Plug in 9, they should have gotten a 68.47. They got an 87, so they overperformed by 18.53 points. If you want to earn at least an 80 in the class, then how many you should really miss no more than how many days according to this model. You plug in 80 for your y hats. You're searching for X. Subtract 93.49. Divide. So if you miss 5, your grade would technically be lower than an 80. So it should be 4 or fewer days. Who would have the largest residual? Okay, we're talking about absolute value here. A person who missed 3 days and earned a 95. Or a student who missed 12 days but earned a 77. Student that missed 3 days should have gotten an 85.15. They got a 95 in real life. They overperformed by 9.85 points. Student missed 12 days should have gotten a 60.13. They got a 77. They overperformed by 16.87. That is the largest residual. So they actually overperformed the best. And there's my dog, who might be your dog. The Price is Right. Okay, so here's 14. Suppose that the taxi and takeoff time, we've done the commercial jet one for so long, has a mean of 9.5 minutes and a standard deviation of 2.9 minutes. What is the probability? That's 50 jets on a given runway. Total taxi and takeoff time will be less than 470 minutes. Well, folks, that's not an average. You need to find the average by dividing 470 by 50. That's 9.4. So it really wants to know those 50 jets, what's the probability that they will average less than or equal to 9.4 minutes for that. Okay, central limit theorem, x bar minus the mean divided by the standard deviation divided by the square root of n. There it is. Be careful with the calculator. This is a less than, so I'm going to keep that area. What's the probability that the mean time will be more than 9.6 because you take 480 divided by 50? All right, folks, that's just going to be 0.10 divided by that same standard deviation divided by the square root of n. So it's going to be the opposite z-score, 0.24. If you look that up, that's the complement of 4052. But I want the area to the right, which means I have to subtract. I get the same answer of 4052, which is sometimes a problem on this next part, because we already know the areas, but it's not going to be 0 because the true area corresponding to this z-score was 5948. You got to subtract the 4052 from it to get 1896 and not 0. All right, a few more questions in this video. Male heights are normally distributed with a mean of 69.3 and a standard deviation of 2.8 inches. What's the probability that a random sample of 25 males? Yes, I know that is less than 30, but because heights are from a normal distribution, I can have a sample size less than 30 and still use Z with no issues at all. What's the probability that a sample of 25 males will have a mean height of at least 70.5 inches? There's your probability statement. You need X bar, not X, because you're looking at a mean here. All right, there's our formula. 2.8 divided by square root of 25 is a nice number. Now I want to know the probability that their average is greater than that, so I have to do 1 minus that area corresponding to that z-score. What is the probability a random sample of 25 males will have a mean height of at most 68.5 inches? All right, my z-score. I want the area to the left, so I keep that. And then what's the probability that my sample of 25 males will have a mean height between those two? I already have those two areas corresponding to the z-scores, and I just subtract them. And folks, how about one final page here, maybe? Suppose you have a sample of 150 values from a population with a mean of 512 and a standard deviation of 108. Might be close to some old SAT, either math or verbal scores. Find the probability that the sample mean will be in the interval of 500 to 524. What's the probability that X bar is going to be between 500 and 524? Same formula I just used in the previous example. Z is 500 minus 512 over that 108 divided by square root of 150. Z is 524 minus 512. Notice they're going to have opposite Z scores. Divided by that 108 over square root of 150. All right, then subtract those two areas associated with those Z-scores, and there you go. What is the probability that the sample mean will be greater than 530? Probability X bar greater than or equal to 530. We'll already have the, I do not. There it is, there's my Z-score. If X bar is 530, it's 204. Look that up, that's 9793. I gotta subtract it from 1 though. I wanna know what's the probability that I get a pretty sharp group of 150 students that overperform by that much. All right, we're going to end on 17 and 18 here for this video. When a pair of fair dice are rolled, what is the probability that the sum is 6 or 7? Given that the sum is less than 10, there are 36 sums there, 6 by 6. I know some of them, you can really only get between a 2 and a 12. So, you know, when I say there's 36 sums, that doesn't mean 36 unique ones, but 36 there unique ways. A 2 and a, rolling a 2 then a 6 would be kind of different as rolling a 6 then a 2. All right, there you go. 36 choices. So what's the probability that X is 6 or 7, given that X is less than 10, X is the sum? 5 different ways to roll a sum of a 6, 6 different ways to roll a sum of a 7. That's 11. And there are 30 sums that are 10 or less than 10, because there's 6 sums that are 10 or more. That's your probability. Made a typo again on 18 here. I've done that the whole year. You spin a spinner labeled 1 through 5 repeatedly until you observe the first one, at which point you stop. Let X be the total number of spins. Find the probability that X is less than or equal to 3. So the probability X is 1 means you spin a 1, and you have a 1 out of 5 or 0.20 chance probability of doing that. Probability X is 2 means that you don't roll a 1, or spin a 1, 0.80, and then you do roll a 1, or spin a 1, 0.20. Probability X is 3 means you don't, and then you do. Add up those probabilities, 0.488. And folks, we're going to end this second video with that. Yak Math Video signing out.